I thought I had it all together, but I was led astray. The day you walked away, you were the clock that was ticking in my home. Changed my state of mind.
Ladies and gentlemen,
Love so hard to find.
we got him.
FBI, open up!
I caught you red-handed, Bug Light. Nowhere to run now. You're going away for a long, long time after we found out what you've done.
What? Well, how did you find me?
It was simple. All I have to do was hack into your mainframe, bypass your firewalls, and triangulate your location.
But,
Shut it, scumbag. You're under arrest for solving identities and manipulating both sides of the equation. People like you disgust me.
what? You can't do both sides?
You're trying to prove the identity, criminal. You don't know yet that both sides are equal.
Okay, I guess you can take me away now to atone for my sins.
Just hold on a second. For your good behavior, how about instead of prison time, I help you and begin to learn some trig identities together.
Okay, thank you so much, Agent Yang.
Okay, criminal. Let's start off with the basics. When given any identity, you need to know how to pick which side to start manipulating. Always pick the more complicated looking side and simplify it to match the other side, the easier looking side. So in this example, this is a more complicated looking side, so you would start manipulating that one to make it end up equaling the more easy looking side, since you can only change one side at a time.
Huh?
Okay, let me put it into more criminal terms. You can take the oregano out of your weed, but you cannot make weed using just oregano.
Oh, that makes much more sense.
Alright, pop quiz time, convict. What are the three primary identities?
I'm not a complete idiot. The first is the Pythagorean one. Cos squared theta plus sine squared theta equals 1. Named after criminal mastermind Pythagoras. Guy was a real prick back in the day. Always mumbling about some triangle something or other.
That's right. When you see cos squared theta plus sine squared theta, you can replace it with 1. It goes both ways, just like how you can go in and out of jail. So if you see a 1, you can also try replacing it with cos squared theta plus sine squared theta and see if that will allow you to simplify it more. I can show you an example if you want.
Yeah.
See, in the first example, at first glance it doesn't seem to simplify, right? But if we replace 1 with cos squared theta plus sine squared theta, then the sine squared theta can cancel out this sine squared theta, so you're left with cos squared theta all over 2 sine theta cos theta, and that allows you to simplify.
Enough chit chat, scumbag. What's the next identity?
Okay, I know this one for sure. We have the two double angle identities. They're useful for changing expressions containing the sine, cos, or tan of a double angle into a single angle, creating more easily cancelable terms. The first one is sine 2x equals 2 sine x cosine x. If you see sine 2x anywhere, the first thing you should do is convert it to 2 sine x cosine x. So I think of it as seeing a baby with candy. You can just take the candy. Let me take you guys to another example. So as you can see here, we have a single angle in the numerator and a double angle in the denominator. It doesn't really seem that we can cancel these out at first. But if we apply this identity, we can have a single angle in the numerator and the denominator. So now we can take the cos theta out of the numerator and the denominator, and we're left with cos theta over 2 sine theta.
I mean, no to the baby stuff, but yes. More often than not, you'll find that converting double angles into single angles allows you to create the same terms in the top and bottom of the fraction, which can then be cancelled out, such as an example that TJ just showed. The pork chop. Next up, we have the second double angle identity, cos of 2 theta. This one is the trickiest of them all, since it can become many things. It can become cos squared theta minus sine squared theta, this one, or it can become 1 minus 2 sine squared theta, this one, or it could even become 2 cos squared theta minus 1, the last one.
Geez, Agent Yang, that's a lot of options. Which one do I choose?
Well, think of it like Fortnite. You have to choose a weapon that best fits the combat situation. The rule for picking which one to use depends on the context of the other variables.
For the last two options, that being 1 minus 2 sine squared theta and 2 cos squared theta minus 1, you pick the one in which you're most able to simplify the terms that are close to it. Here's some examples. For this one, since there's a plus 1 beside the cos 2x, if you choose the 2 cos squared x minus 1, then the 1 and the minus 1 cancel, and that allows you to simplify to sine x over cos x. Now for the second one, since 2 sine squared x is added to the cos of 2x, then obviously you would choose the 1 minus 2 sine squared x, so that those terms cancel and you're left with 1. So like, these are just two examples, right? But obviously there's going to be a lot more like scenarios, so just pick the one that best suits the situation. Alright, so for the first option, while it can be used in cases such as in these examples where it's added to something that can be cancelled out, it can also be used in another special way. So because the first option, cos squared theta minus sine squared theta, can be factored into this, there are some cases in which you will find one of those terms on the other side of the division line. For example, in this case, you have this in the numerator and this in the denominator, right? So if you choose to use cos squared x minus sine squared x, then you can factor out the minus 1 here, and then you can also factor this into this, and that gives you two like terms which can cancel out.
Now, my young Padawan, you've forgotten something small, but very important.
Is it to write QED after I solve each identity? I still don't get how a quantum engineering degree helps with identities, but...
9. Well, that is certainly very important. You forgot the tangent function. Whenever there's a term involving tangent, or tan, split it up into sine over cosine, or sine theta over cosine theta, or you'll be unable to apply any of the identities we just learned. In addition, note that cosecant of theta is equal to 1 over sine theta, secant of theta is equal to 1 over cosine of theta, and cotangent of theta is equal to 1 over tangent of theta, or cosine theta over sine theta. Since all of our identities revolve around sine and cosine, be sure to convert all reciprocal identities and tangent identities into terms of sine and cosine.
Oh, I get it. So I have to convert it into a form that I can use it in. Oh, that reminds me of stealing gold bars from Hemian's Jag and melting it so I can sell the gold to Shiv on the black market.
Allegedly, and of course you're right. At the end, once you've proven something, of course, remember to include the 3 dots, 1 at the top, 2 at the bottom, and QED. That ensures you are finished. Now, to test your abilities, here's a question for you. If you get it right, you're free to go. But if you get it wrong, you're going to jail, scumbag. You have 2 minutes.
Alright, here's your question. You have 2 minutes, starting now.
This looks like the complicated side, so I'm going to manipulate this one. We know that 1 equals cosine squared x minus sine squared x, so we can substitute. We multiply the second fraction's numerator and denominator by cos x. We get a like denominator of 2 sine x cosine x, so we can combine and add the numerators. We replace the sine 2x in the first fraction's denominator with 2 sine x cosine x. To cancel out the 1s, we replace cos 2x with 2 cos squared x minus 1. Simplify into cotangent x.
Good job, Pug Life. You did it. You learned trig identities.
Thank you so much, Agent Yang. Or should I say, smell you later, Jerry Berry, because I got your wallet and I got your gun! Ah, fuck. Scheiße.